Hey, what's up guys? This is 3.5 this week. We're continuing graphing. So far we've learned how to graph quadratics in various forms. Last time we learned how to graph using vertex form, and the time before that we learned how to graph using standard form. This time we're going to graph a quadratic when it's in what is called intercept form or factored form. So this right here is intercept form. And you should already be familiar with intercept form. You've seen a function in intercept form before, or you've seen a quadratic in intercept form. And much of what we did in the last unit, we talked about how to find factors, or how to take something that's in standard form, like ax squared plus bx plus c. We took this and we put it into factored form. So we know how to get it into factored form. And the reason why we put things in factored form is so that we can find x-intercepts, which is also why this is called intercept form, is because these factors right here are intercepts of the quadratic function, right? So just for example, for this first function right here, if we're going to graph this quadratic, which is in factored form, so right here, first of all, I can show you right here, if I multiply this binomial and this binomial together, I get x squared minus 5x plus x minus 5, which is x squared minus 4x minus 5. So you see here, this is in standard form. This is in standard form, and then this is in factored form, right here. So let's graph this. This is actually a pretty easy way to graph this, but let's go ahead and draw our y-axis right here, and draw our x-axis right here. So to graph this, we already know where the intercepts are, right? So we want to find the intercepts using this quadratic. So to find the intercepts, we need to know what the value of x is when y is equal to 0, or f of x is equal to 0. If we know whenever f of x is 0, then we can solve for x. So let's do that. Let's go ahead and take f of x, but we're going to replace it with 0 is equal to negative x plus 1, x minus 5. And then according to the zero product property, if x plus 1 times by x minus 5, if the product is 0, then that means either this or this is equal to 0. So let's take those right there. We know that x plus 1 can be 0, or x minus 5 can be 0. So here, if we solve for x, x would equal negative 1. Here, x would equal positive 5. So we know that whenever f of x is 0 or y is 0, so at this line right here, we know that x is equal to negative 1 and positive 5. So at negative 1 and positive 5. So those are x-intercepts. Now the question is, how do I find whether or not whether the vertex, whether that's a max or a min? Well, that depends on, again, whether or not the graph is positive or negative. So you see here, we have a negative outside here. So that means there's a reflection, so we know that we're going to have a max up here. So we need to find the vertex, but how do we find the vertex? So to find the vertex, we need to find the axis of symmetry. Now if you think about this, I know that these points right here are 1, 2, 3, 4, 5, 6 units away from each other. They are 6 units apart, which means, remember that this is a symmetrical graph. That means halfway between these 2 points will be the axis of symmetry. So that means 1, 2, 3 is going to be the axis of symmetry. because the axis of symmetry, because this is a symmetrical function, right? So 1, 2, 3, 1, 2, 3. There's the axis of symmetry. So I know the vertex is on this line right here. So the axis of symmetry is at x is equal to 2. So if I know the vertex, that means is 2 comma y. So what is y? So I can plug this into the function. So I can do f of 2 to find what y is when x is 2. So this would be equal to negative 2 plus 1 times by 2 minus 5, which is equal to negative, that's going to be 3. 2 minus 5, that should be negative 3. So overall that should be positive 9. So our vertex should be at 2 comma 9. So that should be somewhere up there. 1, 2, 3, 4, 5. So it should be somewhere up there at 2 comma 9. There you go. So that's how you graph using intercept form. So to graph, you need to find intercepts. Find intercepts. You need to find the axis of symmetry. And then you need to plug x value into function to find vertex, to find max or min. And that's how you do it. So just think about it logically, and it should be pretty easy. This right here is just a summary of what we've just learned. So we know that these are what we call intercepts. So notice that this is minus and this is minus, so the intercepts are both positive, right? So if you had positive p, that would mean that this would be negative p. If this were positive q, that would mean this would be negative q. So these are what you call the intercepts because you have to use the zero product property and solve for x. And then the axis of symmetry, again, it's halfway between the points. So here's the point, and here's the point, and here's the axis of symmetry. So what you could do instead of counting the number of units in between them, you can use this equation right here. What you can do is you can take the p value, take the q value, and add them together, like right here, and that will give you the distance between them. This would be p plus q, and then you would just have to divide by 2 to find the halfway distance. And then whenever a right here is greater than 0, that means it opens downward, or sorry, it opens up, and then it opens down if a is less than 0. So right here, graph the function. Graph the following function by converting the function from standard form into intercept form. So this right here is in standard form. So let's put it into intercept form in order to graph this. So how do you convert a function in standard form to intercept form? You have to factor. So here, if we want to factor, so whenever we're factoring when x is equal to 1, or sorry, not when x is equal to 1, when a is equal to 1, so again, a is equal to 1, to factor that, we need to find two numbers that multiply to be negative 15, but add to be 2. So let's think of two numbers that multiply to be negative 15. So I know 1 and 15, 3 and 5 right there. So which of these pairs multiply to be negative 15, but add to be 2? Sorry, that should be positive. That should be 3 and 5. So that would mean I have to be positive 5 and negative 3. So positive 5, negative 3. So I can factor this to be x plus 5 and x minus 3. So I know my p and my q values right here. These are the p and the q values, but the opposite of them. So that means you could say p, or you could say, let's just say x. So we know x plus 5 equals 0, x minus 3 equals 0, so x would equal negative 5, x will equal positive 3. Okay, so let's go ahead and let's graph those. So we know, let's see, I'm going to graph it probably starting right here. Here's my y. I'll draw my x-axis right here. Actually don't know where the max or the min is going to be, but I do know again that 1, 2, 3 is an x-intercept, and 1, 2, 3, 4, 5, negative 5. So these are the x-intercepts. 1, 2, 3, 4, 5. Yep. Okay, so we could count the midway distance between these right here, or we can use our formula. We knew that it's p plus q divided by 2. So we know these are our p and the q values, so we can do negative 5 plus 3 divided by 2. So that would equal negative 5 plus 3, that should be negative 2, and that's over 2, so it's equal to negative 1. So this is the axis of symmetry. 1, 2, 3, 4, so right there. And you can see that that's the halfway point, right? 1, 2, 3, 4, and 1, 2, 3, 4. So there's our axis of symmetry. So we use that by using this equation right here. Okay. So we know that our max or min is on that line. So do we have a max or a min? Well, A is positive, so that means we're going to have a minimum value, so this is going to be open upward. So to find that, we have to plug in, we know that the x value, so we just need to find the y value. So we plug negative 1 into the function to find it. So we can do negative 1 plus 5 times by negative 1 minus 3. So this is equal to 4 times by negative 4, so it's equal to negative 16. So our graph will be down at negative 16. If we wanted to, we can count by 3, so this could be 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, so then 16 should be like right here. So our function should be, oh sorry, right here on the axis of symmetry, not on the y-axis. So it should come down, and just like that. There you go. Okay, let's come down here. Oh, first of all, we haven't really talked about the domain and range, but we should know how to do that. So the domain is always all real numbers. We've already talked about that before. For quadratics, it's always all real numbers. Now for the range, it starts at the min or the max. Remember that range starts at min or max. Well, I guess you could say it starts at min or ends at max. Sorry. So starts at min or ends at the max. So in this case, we start at 16. So negative 16, and we go to infinity. However, up here, sorry for the example that we did up here, we go from the domain, again, is all real numbers. The range then starts at negative infinity and goes to 9. Because it's a max, so it ends at the max. Okay, so let's find the zeros of the function. So what is the value of y at the x-axis? The value of y is 0 at the x-axis. So again, if this is a graph, this is the x-axis, or it's when y is equal to 0. And the zero product property is that a times b, if a times b is equal to 0, then a equals 0 or b equals 0. Okay, so finding the zeros, if we want to find the zeros, this is another word of saying intercepts. Okay? We need to know value of x when y is 0, hence finding the zeros of the functions. So when y is 0, that means we have to take f of x and make it 0. 0 is equal to x minus 1 times by x plus 2. Alright, well again, using the zero product property, you could say that this is a and this is b. Well, if these are being multiplied together and the product is 0, then a equals 0 or b equals 0, or in this case, x minus 1 equals 0, or x plus 2 equals 0. Well, if x minus 1 equals 0, that means x would equal 1. If x plus 2 equals 0, then x would equal negative 2. So these are what you call the zeros of the functions, or intercepts. Alright, so writing quadratic functions. So here it gives us, for a, it gives us a function, or it gives us a vertex. And for b, it gives us some points at which it passes through. So we want to write a quadratic function in standard form whose graph satisfies the given conditions. Okay, so a, it has to have a vertex of negative 3, 4. And it passes through these points right here. So you notice that here, though, right here, remember, these are coordinates of x and y. So here, you can see that the y is 0 and the x is a value. So if y is 0, that means these values right here are your x-intercepts, so at negative 2 and negative 9. So those right there are x-intercepts. So we know that x is equal to negative 9 and x is equal to negative 2. Okay? Knowing that, I'm going to work backwards. See up here, we ended here. And we got this from solving for x. So these are factors right here. This is what you call factors. These are zeros. So let's take our zeros and put them into factors. So to do that, let's add 9 to both sides, or add 2 to both sides here. So then we get x plus 9, and we get x plus 2. These are the factors that make up our function. So we know that f of x is equal to a. We don't know this value yet, but we know that the factors are x plus 9 and x plus 2. So we do know that much, okay? We also know that this right here, that we pass through this point right here. Remember that this is an x and this is a y value. So what we can do is we can take this x and this y value and plug them into this equation, because then we'd have x, we'd have y, and then we can solve for a. So what I mean by that, so let's go ahead and instead of, so this is y, right? So let's go ahead and replace that with 20, because that's what y is right here, is equal to a times by x, which is negative 4. X is negative 4. Okay, so you see here that the only unknown variable now is a. A is the only unknown variable. Since it's the only unknown variable in the equation, we could actually solve for that now. So we know 20 is equal to a times 5 times by negative 2. So we know 20 is equal to, that should be negative 10a divided by negative 10. So we know a is equal to negative 5. Alright, so let's go ahead and take our equation again and rewrite it, but using a equals negative 5. So we know f of x is equal to negative 5 times by x plus 9 times by x plus 2. But again, we want to write the quadratic function in standard form. this is in factored form. So what we can do is we can FOIL everything out. So we know f of x is equal to, so I can distribute those together, so I get x squared plus 2x plus 9x plus 18. Remember that this is all being multiplied by negative 5. I should have wrote that first. But f of x is equal to negative 5 times by x squared. I can add these, plus 11x plus 18. So this is equal to, now I can multiply everything by negative 5. So it's equal to negative 5x squared minus 55x minus, the question is, what is 5 times by 18? So I'm going to pull my calculator. 5 times 18 equals 90, so minus 90. So f of x is equal to this right here. And there you go. Alright, so what to do here, if you guys want to, if you want to practice your graphing, is find the zeros, use the zeros to graph the function. So go ahead, you have to put this into factored form to find the zeros. This one's already in factored form, so you just have to find the zeros. But again, that should be everything. You can do these for extra practice. If you have any questions on anything that we covered in this video, make sure to email me. If not, I'll see you in class.